Hello everyone, welcome to next video tutorial on the trees. It is an last module of data structure. In today's class, I am going to explain the basic concepts of the graph. Okay, in that the graph, uh, the basic concepts are the how definitions of graph, vertices, edges, and terminology, and how to represent the graph. Okay. Uh, in today, already we know that what is a graph. Graph is a combination of both vertices and edges. Or you can say it is a pair of vertex and edge. When any graph is given, it contains the node, and each nodes are connected by certain lines. These lines are nothing but the edges. Okay. Each edge is defined by pair of vertices. In order to draw an edge, I required two vertices. That is why a pair of vertices are required to connect an to make an edge. Okay. Then vertices are also called as the nodes, and for each nodes I can specify the label. For example, node 1 I can denote this vertex with the label A, like that. Then here represent the vertices. A graph can be represented with the vertices with the circles, and for each nodes we can specify the label. In the given example, in this example, these contain the four nodes, and how many edges are there? From A to B one edge, B to D another edge, similarly third edge, fourth and fifth. Total five edges are there that are connected between uh, these nodes, or you can say these vertices. So these five edges are AB, then AC, AD, BD, and CD. These are the vertices. And example of a graph application, like how we can make use of these graphs in real-time applications, like cities with distance between two cities, then connecting roadways, then course prerequisites. For example, I'm going to cover these five modules in how many hours, and how they are connected to each other, whether I'm following from the first module to continuously until 5, or I can teach first and second, and then I take some break, then I will take the fifth module. After that I will cover second and third, like that. The prerequisites will be there. Okay. Then graph classification, there are different graphs are there, like weighted or unweighted, directed or undirected, cyclic or acyclic, then multigraph. The kinds of graph, weighted and unweighted, is the weight nothing but the cost. Okay. For each node, from each node to another node they will be connected by an edge. Each edge if contain any number, or you can say the value, that can be considered unweighted. Okay. If edge is not contain any value assigned to it, or you can say any cost not assigned to it, that time it is unweighted graph. Okay. Like weighted, example of an weighted graph is weights are distance between the cities. Like if I said the distance between Bijapur and Bangalore is 540 kilometers, that 540 indicate that it is a weight. Okay. Similarly, an undirected graph, like course prerequisites, it will just define that how we go from first model to another model. For that we are not specifying any weight for it. Okay. Then directed and undirected graph. Directed graph is in each graph, uh, each of the edge contains some direction. Or you can say that from A to B there is an edge that indicates that we always go from A to B. Okay, that is the way we are traversing. It indicates an arrow mark. That is directed one. If it is not contain any direction, that time we can traverse from either A to B, or from B to A. Both remains same. Okay. Mm. Then graph can be classified by whether or their edges of direction, like we have seen arrow. Then undirected graph is each edge can be traversed in both the direction. As I told, I can go from A to B, or I can go from B to A. Okay. Undirected graph, no implied direction on each edge between nodes. Like in this is the example for the undirected. There is no arrow here. Okay. This example is called an undirected graph. Then, in the continuation part, in an in undirected graph, an edge is an unordered pair. Like in the directed, we can say that from A to B, then B to C, then C to D. But here, there is not an ordered one. Either I can take it as A to B or B to A. Both remains same in an undirected graph. But in a directed graph, if I written A to B, indicate that there is always A to B is the correct one. If I write in place of A to B, if I write B to A, that time it becomes a wrong one. Okay. So above is the example of undirected, and then the today this one is the example for the directed one. Okay, each edge contain the arrow, and we can say that we can travel towards only that direction where the edges will begin and ends. If I take that from the A, it will begin. At B, it will end. It indicates that I can move from A to B, not from B to A. Okay, and at same time you can specify the uh, degree of an uh, directed graph. It means that degree 2, B and C here, B and C are degree 2, means that from this how many edges are connected. Okay, then A and D have odd degree. Okay, so how many edges are leaving from A and D is from A it is 3. Then D, how many vertices are going? Only 1. That is A is 3, D is 1. A is 3, D is 1. Both are odd degree. B and C, what is the degree of it? From B, it is one incoming and one outgoing. Similarly, here also it is for C, it is one incoming, one outgoing. It becomes 2. For the D, we have 1, 2, 3. For A, 1, 2, 3. Total input and output becomes A and D out, B and C even. Okay, and we can say number of edges are pointing to a node is in degree. Number of edges pointing away from the node is out degree. Here I just mentioned degree. It can contain both even incoming and outgoing. Or if you want to specify individually, that time what is the in degree of B? In degree of B is 1. In degree of C is 2. In degree of C is 2. In degree of D is 2. Out degree is 1. But similarly for A, in degree is 0. Out degree is 3. Then path, a sequence of vertices in which each pair of successive vertices connected by an edge. Okay, the path we can say that path in which it begins with one vertex, ends with another vertex, or you can say that source will be different, destination will be different, and these are source and destinations are connected by the edges. If I say A is the source, D is the destination, then how I travel from A to B, B to D. These two are connected by the edges. Similarly, cycle. Cycle is we start from the same vertex and it ends with the same vertex. For example, if I say A is the initial vertex and I have to come back to the same vertex after traverse through the different nodes. Like I can go from A to B, B to D, then D to A. Similarly, I can go from A to C, C to D, and D to A. Finally, I came back to the same vertex. Okay. Then simple path. A path does not cross itself. That is, no vertex is repeated. Okay. If I start from A, I have to reach D. Then that I have to move from either A to D, or I can move from A, B, D. Okay. Even though if one more vertex is there, then it should not be repeated. And simple path cannot contain cycle, means that it will not in between there will be no same vertex begin and same vertex ends. It always contain the unique nodes between the path. Then length of path, how many edges are there from the source to destination, that will be considered the length of an path. Like A to B 1, B to D 2. From A to D path we have two edges, hence length of the path is 2. Then cyclic and acyclic graph. Cyclic graph, if the graph contains cycle, then it is acyclic. Okay, if the graph not contains cycle, then it is acyclic. For example, roads, if I start from college, I'll reach my home, then in the another route I can come back to the uh, college, so that becomes a cycle. Okay, then if there is no uh, from beginning and come same end is there, that time we consider it is not the same end, that time it is course prerequisite. Like I can start for the course at one position and I can complete at module 5. Okay, and I will not come back to the module A again. That is what is called course prerequisites is an acyclic graph. Then multigraph. A graph, multigraph is nothing but from between two vertices there will be more than one edge. Like here A to C. A to C, how many edges are there? 1 and 2. Similarly, B to C, there will be a 2 edge. So you can say that multiple edges or parallel edges between two nodes. Okay. Then connected and unconnected graph and connected components. Okay. An undirected graph is connected if every pair of vertices has a path between it. Okay, an undirected graph is nothing but there is no the edge it not contain the arrow with the edges. Okay, and every pair of vertices between the path is connected. That time we say that it is an connected one. Okay, then otherwise it is unconnected. A directed graph is strongly connected if every pair of vertices has a path between them in both the direction. Okay, for example, if I say I'm moving from A to A, I'll go from A to B, B to C, C to A. There will be a two paths are there in both directions. That time we say that it is an strongly connected graph, directed graph. Okay. The next one representation of the graph that will explain in the next video. Thank you.